So from the previous videos, we know that the UE has to send the uplink signal in advance, and that advance depends on propagation delay and uplink to downlink, switch delay. It also depends on BTS to BTS synchronization error. Okay, this time is particularly defined and it's fixed based on the deployment scenarios, and this time is always calculated and communicated to the UE, and this also take care of the round trip propagation, not just the one side. So UE has to send the signal in advance by 2 into propagation delay plus this parameter we have represented in terms of anti offset, which is represented in terms of TC. Okay, so this much time UE has to advance the uplink signal. Okay, now this number also let's define in terms of TC. So 2 into delay, I'll just write it delay by TC plus anti offset into TC. Now this number, this particular number, I am going to call anti-A. So it becomes anti-A plus anti-A offset multiplied by TC. Okay, so the G node B will calculate this propagation delay, okay, based on the PRAT signal sent by the UE, and it has to send this delay back to the UE. Okay, but G node B does not send this number anti-A directly to the UE. Instead, it quantizes this number and sends, and this quantization also depends on the sub-carrier spacing. So what G node B sends to the UE is not anti-A but something called TA. This TA is nothing but the quantization of anti-A, which is 16 multiplied 64 divided by mu. This depends on the sub-carrier spacing, or if we rewrite, the 38.13 says anti-A as TA multiplied 64 into 16 by to the power mu. This is what the spec says, so I have just rewritten it in a different way. Okay, so this quantization depends on sub-carrier spacing as well. Why? Because for different sub-carrier spacing, the symbol time is different, the cyclic prefix is also different. Okay, so the impact of this quantization should also be different, or this quantization should also be different for different sub-carrier spacing. So basically, when we go up in the sub-carrier spacing, when we use higher sub-carrier spacing, then the symbol time will be less, so the quantization should be better. Okay, so now from our previous example, let's calculate this number. Okay, so when the UE was 2 km, we had this example G node B UE, the distance is 2 km, the single sides the propagation delay is 6.66 microseconds, both sides it is roughly 13.33 microsecond. Okay, so first we'll calculate this number NTA, basically delay in terms of TC. Okay, so NTA will be 13.33 divided by TC is 480 kilohertz into 4096, which is roughly 26214. This is our NTA. Okay, now instead of sending this NTA directly to the UE, G0B will quantize it and convert TA, where TA will be NTA, which is 26214 divided by 16 into 64 divided by 2 to the power m. Okay, now if you consider 30 kilohertz of spacing, in that case will be 2 since mu is 1, so TA will be 26214 divided by 16 into 64 by 2, which is roughly 51. Okay, so the G0B sends this number 51 for this delay, for the when the U is 2 km, when it is the delay is propagation delay, round trip delay is 13.33 microsecond. Then this is the number that G0B sends. Now let's understand this. When UE sends PRAJ, okay, PRAJ signal is designed in a way that G0B can calculate propagation delay, and different PRAJ formats are designed, okay, to cater different cell size and for different deployment scenarios. So G0B calculates the delay. Okay, from this delay it calculates NTA and it calculates TA. This TA, this timing advance, is sent to the UE in the next message. So the G0B will send this TA to UE. UE will apply this timing advance, and from every uplink message from that time onwards, okay, whenever it transmit, whether it is PU, CCH, PU, SCH, SRS, it has to apply this timing advance. Okay, so UE will calculate back. So once UE receives this TA, let's in this case 51, so from 51 it has to calculate NTA. So NTA will be 51 into 16 into 64 divided by 2 to the power mu, so roughly 26214 it will calculate, and then it will calculate TTA, this timing advance, which is nothing but NTA plus NTA offset multiplied by TC, and you will advance its uplink by this much time. Okay, thank you.